So this is a fun little problem because it's got multiple parts to it. Specifically, when we attack part A here, there's actually 2 steps to the calculation. So you got a couple who's thinking about retiring in 50 years. They'll need $30,000 a year in their retirement. They plan to be retired for 25 years. They believe they can earn 8% interest. So the first thing that we have to ask ourselves is, how much is it going to cost them to buy that annuity? So the annuity that they're going to purchase into retirement, present value, future value, payment, rate, and N per, has to be sufficient, I spelled annuity terribly wrong there, to give them a payment of $30,000 at a rate of 8%. It's going to last them for 25 years. Let's notate that these periods are years, that the rate is then annual, and that the payments will also be yearly. And so the question is, how much would they need to have saved up at that point in time? So at the point in time where they went to buy the annuity, it would be their present. So we're solving for present value in that case. 8%, 25 years it would last, of getting paid $30,000, which says then they would need $320,243 saved up. So that's the first part of the problem. The second part of the problem is, so how are they going to save to get there? So the savings period is going to be the period during which they are actively working, and since they're going to retire in 50 years, we'll go ahead and copy and paste this stuff over again. Let's widen up our columns a little bit here. Same here. Okay, so that savings period is going to be a 50-year period where they will also earn, they believe, 8%. And the question is, how much will they need to put away every year in terms of their savings plan this time so they can achieve a $320,000 future value? And notice I went ahead and switched the sign on that just because it makes more sense to me to have that be a positive number, so that when we get this payment, it should be a negative number. So at the rate of 8, 50 years worth of savings. There's no money that they have right now to put away, but they need to get to the $320,000. Says that they need to save about $558 per year. Now, the nice part about doing second component, letter B in this, how would this change if they realize that in 20 years they'll need to spend $60,000 on their child's education? We'll make some simple assumptions here. Assumption number 1 is they're going to save up to 60 grand so that their child will go to school and then they'll just plop it down at one time, as opposed to making 4 years worth of payments. But the other nice part about that is that the way that this works is they're actually independent of one another, so that the answer to A doesn't really change other than by a marginal amount. And that marginal amount would be the $60,000 that they need to have saved for when their kid goes away 20 years ago at, 20 years should be down here, 20 years from now, and they're not going to make a payment. They are going to save in terms of a payment. They do not have any money saved up right now for their child. So the answer would be, how much additional would they need to save at 8% for 20 years? And they have no money right now and they need to get to 60 grand. They need to have another $1,311. So the total amount of their savings, if they wanted to both retire and send their kid to college, would be around $2,000 per year. Hold on, I forgot to put the addition sign. There we go. And I did it wrong again. E11. And then that one is C17. Okay, we're getting close here. There we have it.